Okay, thank you. I'm Shota Yamanaka from Yahoo Japan Research. In this study, we analyzed touch pointing performance with distractors. In this study, users have to tap the green target, but when users tap pink distractors, users have to wait for a penalty time to finish. So users should avoid tapping distractors. In this situation, if the gap between the target and the distractor is large, users don't have to pay attention to distractors. But large gaps occupy large screen space, so the gap cannot be so large. After the experiment, we recommend using 1 millimeter for gaps. Okay, first, I explain the background of this study. Some research and guidelines recommend using, of course, large targets and large gaps. For example, the optimal target size is larger than about 70 millimeters, and the optimal gap ranges from 3 millimeters to 6 millimeters. However, these guidelines show the optimal values for large touch screens like ATM kiosk terminals. So these guidelines cannot be directly applied to GUI designs for smartphone apps or tablet apps. For smartphone apps or smartphone web pages, there are small targets and small gaps, both in 1D and 2D conditions. On the left side, this example of 1D condition shows that I want to tap the button labeled shipping and handling charge, a very small button. But there is a big orange button above the intended target. So I have to carefully and slowly tap the intended button to avoid tapping the orange button. But if a gap between these two buttons is very large, the web page height increases, and thus users have to perform many scrolls to see the entire page. So the balance between the operation speed and screen space management is important for GUI designs. In this case, if users accidentally tap distractors, an additional time is needed to recover from the error. For example, when users tap unintended hyperlinks, first, users return to the previous page. Second, users wait for the previous page to finish reloading. And third, users try to tap the intended hyperlink again. So these successive operations would take 5 seconds or 6 seconds. To simulate this recovery time, in our experiment, we add a penalty time if participants tap a distractor. But in contrast, tapping empty spaces doesn't need such an additional time. So users just have to try tapping the intended button again. So in our study, we separate tapping distractors from tapping empty spaces. So the idea of adding penalty times comes from this related work on time cost for pointing misses. In this task, when users click outside the target, the mouse cursor disappears, and users have to wait for a given penalty time to be over. The results indicate that if there is a risk of pointing misses, users become more careful and the operation time increases. Inspired by this related work, in our study, we use this penalty time paradigm. But again, we add a penalty time only for tapping distractors, and tapping empty spaces required no additional time. Okay, to investigate the optimal gap, we have already reported the results of these two experiments. In the 1D condition, we found that the optimal gap was 4 millimeters. But we couldn't find the optimal gap in the 2D condition. In the 2D condition, the white start button and the green target were vertically aligned. So participants just had to move their fingers straight downwards, like 1D conditions. So the effect of gaps on the left side and the right side were not clearly observed. Okay, therefore, in the present study, we conducted a follow-up experiment of the 2D condition. In this task, the green target was always surrounded by 8 distractors like keypads. And we tested 4 movement angles and 4 penalty times. So in this situation, participants had to adjust their finger positions both on X and Y axes. In total, 120 conditions were included. And the goal of this task was to complete an entire trial in as short a time as possible, including the penalty time. Okay, these are the task completion times affected by the penalty time and gap. Pairwise comparisons showed no significant differences for penalty time and gap. This means that the participants performed at the similar pointing speeds for all the penalty time conditions and gap conditions. But smaller gaps have a higher risk to tap on distractors. So the error rate should change depending on the gaps. And this is the result of our main interest, that the number of tapping distractors per trial. On the left side, penalty time didn't show significant differences, but the gap clearly showed the effect. When the gap was 0 millimeters, participants accidentally tapped distractors significantly more than the other conditions. But the gap was, when the gap was equal to or more than 1 millimeter, such a negative effect disappeared, and there was no significant difference. So therefore, to avoid tapping a neighbor distractor, 1 millimeter or more spacing is required. And this is the number of taps in empty spaces. This also showed no significant differences due to the penalty time. In contrast, we found a strong effect of the gap. But tapping empty spaces imposed no additional penalty time. So this increase due to the gap didn't negatively affect the operation time, because the gap didn't significantly affect the results of task completion time. Okay, another recommendation is, of course, using large targets. Large targets significantly reduce the negative effects of distractors. On the left side, the number of tapping distractors per trial was only 0.3% when we used the 7.2 millimeter targets. And the number of tapping empty spaces was only 1.5% for the 7.2mm targets. So in such a large target condition, users can directly tap a target for the first trial. Okay, this is a summary of the experimental results. First, we recommend using 1 mm for gap as the optimal value. And 2 mm or more gap is not needed to reduce the wasted screen space. Another finding is that the penalty time showed only a slight effect on the results. But this is consistent with the previous work that showed the effect of penalty time rapidly disappear. However, this experiment was highly controlled because we used a large tablet and it was flatly set on a table. And the participants were instructed to use their right index finger. In such a condition, the pointing precision was so high. Therefore, in the future work, we plan to conduct a follow-up study using smartphones. In this study, participants use their thumbs for pointing performance. And this posture is the most common style for operating smartphones. And thumb is less precise than index finger. Furthermore, we have already implemented a website version of these studies. So we will conduct a crowdsourcing experiment with more than 100 participants. These experiments will provide a more practical gap value in more natural conditions for each participant. Okay, 2 minutes or 3 minutes left. Additional results. This is a result of Fitts law regression expression. The Fitts law showed poor fit. We assume that the reason is that participants had a different motivation in our experiment. In conventional pointing experiments, participants are instructed to tap a target as quickly and accurately as possible. But in our experiment, participants wanted to avoid tapping distractors. So even if the target size is same, tap point distributions would change depending on the closeness to the surrounding distractors. So the Fitts law effective width method didn't show a good fit. So another negative effect of distractors was that designers cannot predict the average operation time using performance models like Fitts law. Okay, this is a summary of this study. The optimal gap is 1 mm to balance the space occupation and user performance. And penalty time didn't strongly affect user performance. And we hope the result of smartphone experiments will be presented in the future. Okay, that's all. Thank you for listening, and I'm happy to answer your questions. Thank you.
Thank you very much, Shota. We have time for questions. So if you have any, please just introduce yourself at the microphone.
Yes, thank you for your talk, Michael Ripp. So I was wondering, I found your graph interesting concerning Fitts law. So you said Fitts law does not apply. Do you have a suggestion for an alternative formula which may fit your high-risk data better?
You mean the refinement of the Fitts law? Or
Yes, I mean, Fitts law is based on the logarithm, or I mean, that's at the core of Fitts law. And here it seems that your empirical data does not, has more like upward curve here. So did you think about a formula that would fit your data better?
This result shows the profit because here we use the effective width based on the tap point distributions. If when the tap point distribution is large, the effective width is large and the ID is low. So when the gap is large, participants tended to randomly tap around the target because there is no distractor. So the effective width was so high and the ID is quite low. So the Fitts law showed profits. But currently I have no idea to refine the model of the gap conditions.
Okay, thank you.
Thank you.
Any other question? Okay, so if no further question, I will have a quick question for you. So I didn't really understand how you applied the penalty time. So did you add penalties if users were tapping 2 distractors before to perform a correct selection?
Participants had to continue to tap the green target even if they tap empty space or distractors. And if participants tap the distractors twice and then tap the target, if the penalty time condition was 4 seconds, in total 8 seconds were added after the tapping the target.
Okay, and when you analyze the penalty time, the effect of penalty time, you grouped based on how long they had to wait, or what? Yeah, okay.
Yes.
Okay, so if there is no further question, thank you again.
Thank you so much.